Yes, good morning, my dear friends, and also welcome to electronics online classes. Look here in the last class, we are discussing about the different applications of your operation amplifier, and in that different applications, we have completed the major applications. As we know already, by using the op-amp, we can construct a linear devices, linear circuits and non-linear circuits. And also, as you studied already, the operational amplifier can be used in two ways. The op-amp can be used, or the applications of op-amp can be linear applications and non-linear applications. And you are all completed the linear and non-linear applications of your operational amplifier. And today onwards we'll go for the another important special type of applications of your operational amplifier. Already you have completed the why the op-amp is called op-amp, because as we know it will do the mathematical operations, and you are already derived at derivations. How your op-amp can be used as a inverting amplifier, non-inverting amplifier, adder, subtractor, integrator, differentiator, and also you have completed in the last class about how op-amp can be used as a logarithmic and anti-logarithmic amplifier. And today's class you are going for the another most important application of your op-amp, that is it is used as an active filter. And today's the lecture number 9. Today we are going for the lecture number 9. We are going for the lecture number 9. And today onwards we are going for the some special applications of your operational amplifier. And in that special application, the today's application is about active filters. Active filters. It means, as we know already, you are having the operational amplifier can be used as the active filter. Also, it is used in your comparator. It is also used in your A to D converter, D to A converter. That you will study in the today's and tomorrow class as possible. It means you are having so many applications of the operational amplifier. In that so many applications, the one most important application is about active filters. Look here, already you studied in your basic level about in the first year about the filters. And what is filter and what are the types of filter? Today we'll go for once again about in detail about the filters. And as we know that in general being a filter, the filter is a device that will filters the signals, or in general as we know the water filter. The water filter remove the dust particle in the water. It means in the water you are having the pure water, also some dust particle also there in that water. But if you use the water filter, that will remove the dust particle, they will give the pure water. It means in general the filter will filter the things. It means it removes some things. It will remove some dust particles. And in the same way, you take our human being, we are using our nose that acts as a filter. And these are the in basic, in general meaning of filter. But in electronics, what is filter? The filter is a circuit or device. They will filter the signals. Filter means they will allow some signals and they will stop or attenuate some signals. Once again repeat, the filter is an electronic circuit. They will allow some signals, some frequencies, and they will attenuate, they will stop some frequency signals. That is something about the definition of your filter. First you know what is filter. It is an electronic circuit, and by using this electronic circuit or device we can remove some signals and we can allow some signals. Filter is an electronic circuit. This will allow some signals and it will stop or attenuate some signals. Or you can say you are giving importance to the frequencies. The filter is a circuit or device. They will allow some frequencies and they will attenuate or stop some frequencies. That is nothing but the filter. Actually, the filter is nothing but it is a frequency selective circuit. The another name of filter, it is also called as the frequency selective circuit. The filter is nothing but frequency selective circuit. The filter is an electronic device or circuit. They will allow some frequencies, they will allow some signals, and they will attenuate or stop some frequencies of signals. That is in general definition of the filter. But in filter, we are having the nearly in broad. We can classify the two types of filters. One is called analog filters. One is called analog filter. And second one is called digital filter. Digital filter. We are having the analog and digital filter. Look here, depending upon the analog filter will allow the some frequencies. They are working. They are the signals are in the nature of analog nature. Analog filter nothing but here in the analog filter it will work for the analog signals. It will work for the analog signals or it will process the analog signals. But in digital filter it will process or it allows or it stops the digital signals. Analog filter, it is a circuit or device. They will allow or they will attenuate or will stop the analog signals. And actually you are having the syllabus for the analog filters. And also we can classify the filters depending on the frequency, maybe audio frequency filters or maybe radio frequency filters. It may be the EF. It may be the EF audio frequency filters or it may be the radio frequency filters. These are the types of filters, and especially you are having in your syllabus you are having the analog filters. And in analog filters, once again you are having the types of analog filter, that is called active filter and passive filter. In analog you are having the active filter and the passive filter. Analog and passive filters. Look here, what is the difference about active filters and passive filters? As we know, you studied in the first year about basics, what are active and passive components or devices. In active filters, you are having an active device. It may be your operational amplifier, it may be your transistor, or it may be your FET. Along with the passive components, we are using the analog, we are using an active components. That type of filter is nothing but active filters. It means in active filter, we are using an active device or component. It may be your operational amplifier, or it may be your transistor, or it may be FET, along with the passive components. And that type of filter is nothing but active filter. And passive filter, as we know, in passive filter, the filter is constructed by using passive components. It may be your R, C, or L. We can construct the filter by using R and C, or L, or using LCR. The That type of filter is nothing but passive filter. Very simple. The filter is constructed by using both active and passive components. That type of filter is nothing but active filter. And in passive filter, you are only constructing the filter by using the passive components. That type of filter is nothing but passive filters. And the major difference about active and passive filters. In active filters, it is possible to having the amplification is possible, or you can control the gain. We can control the gain, or you are having the amplification possible, and you are having very less losses. You are having the very less attenuation. You are having very less losses, and also the important thing is about you are not having any loading effect. You are not having any loading effect. And but in passive filters, it is not possible. You are not having any amplifications. And in passive filters, the important thing it is not required the power supply. But if you want in active filter, you want extra power supply. But extra power supply, you are not requiring in your passive filters. And also in passive filter contains inductor, but in active filters it is not containing the inductors. It means the important thing about you already studied about passive filters. The passive filter consists of R and C combination, or R and L, or LCR. And in your active filters, it is having a active component along with an passive filter, or along with an R and C combination. That is something about the active and passive filter. The important thing, the major difference about active filter and the passive filter. In active filter, we are having the amplification possible. Also in active filter, we are having the very losses are very less, attenuation is very less, and also we are having the no loading effect. But in passive filters, you are having it is only you are using passive components, and you can use the inductors, and in passive components it is not required the power supply. Externally you are not required the power supply. Whatever the signal, that signal enough for the passive filters. This is the good in simple way of active and passive filters. But in active filters, you are studying in the 4 types of active filters, or in general you are studying about the 4 types of filters. That is nothing but low pass filter, and the second one is about high pass filter, and the third one is about band pass filter, band pass filter, and the fourth one is about band reject. And finally, somewhere given about the all pass filter. Here, as the name indicates, you are having the nearly about 5 types of filters, depending upon the frequency range. Depending upon frequency range, it may be the low pass filter, high pass filter, band pass filter, band reject filter, and finally about all pass filter. Very simple. What is called low pass filter? It is a circuit or device. It allows only the lower frequency. The low pass filter, it allows only the lower frequency, and it attenuates or stop the high frequency signals. Their name indicate their meaning. In low pass filter, that allow only the lower frequency, and the attenuates stop the high frequency signals. And the high pass filter, it allows only the high frequencies and attenuates stop the low frequency signal. And here the band pass that will allow only some band of frequencies. Above and below they will attenuate. Or you can say they will allow some range of frequencies. The band pass nothing but they will allow some frequencies, some band of frequency. Above and below they will attenuate the remaining frequencies. And band reject means it will allow or it will reject some band of frequency. The remaining frequency will allow. Some band of frequency will be rejected, some band of frequency will be passed. That is something but band pass and band reject. All pass nothing but they will allow all the frequencies. All pass filter nothing but they will allow all the frequencies or all the signals. These are the important types of filters. Once again repeat, low pass filter, it is a circuit or it is a device that allow only the lower frequencies and attenuate stop the high frequency signals. A high pass filter, it is a type of filter or circuit, it allow only high frequencies and it attenuates or stop the low frequencies. But band pass, it only allows the some band of frequencies. The remaining frequency will be attenuated. And here band reject, only some band of frequency will be rejected, the remaining frequency will be allowed or passed. That is about band reject and all pass. All pass nothing but they allow all the frequencies. This is about the important types of filters. But as I said, this is about basic, and actually you are having the syllabus for your second PUC. It is about active filters. In active filter, you are studying about the active filter. Active filter. In the active filter, once again, I have done the types. One is called first order. First order, low pass filter, and same thing, a first order high pass filter. And also we have another type, that is second order low pass filter, and finally about second order high pass filter. These are the different types of filters, and actually you are having this syllabus for these two in your second PUC. You are studying in detail about the construction and working the first order low pass filter, and also studying about first order high pass filter. And what is the difference about first order and second order? In first order, you are only using one R and C combination. In second order, you are using more than one R and C combination. What I said, active filters, nothing but it is a type of filter. In this active filter, you are using an active component. It may be operational amplifier or it may be a transistor FET along with the one R and C combination. Or you are using a passive filter. Especially you are using passive filter, you are using about RC filter. Along with the op-amp, along with the transistor, along with your FET, you are using an R and C filter. It means here in first order you are using only one RC filter along with op-amp. But in second order you are using two RC filter along with op-amp. That is something called second order low pass filter and second order high pass filter, first order low pass filter and first order high pass filter. Another difference about first order and second order, nothing but in first order you are having very small losses. But second order is as similar to your ideal filter. The frequency response of second order filter is as similar to the ideal filter. Right? This is about the importance types of your active filters. Now we will go for the most important thing, that is about working and construction of your first order active low pass filter. We are going for the first order, you are going for the first order, active low pass filter. First order low pass active filter. And as I said already, why you are using an op-amp in your active filters? Because you can use the op-amp, or you can use the transistor, or you can use the FET. But the important thing, you are using the op-amp. The first one is why you are using op-amp. First one is because of the amplification. The first reason we want amplification. Second reason is about buffering purpose. Or the third one is about signal isolation. Or it is also called as impedance matching. Why you are using op-amp in your active filter? We want amplification, we want buffering, also we want signal isolation, or you want the impedance matching. And especially as you are using op-amp, the op-amp is used as a buffering amplifier. It is also called as voltage follower. It is also called as unity gain amplifier. Op-amp, why you are using op-amp in active filters? One is about to get the amplification and buffering purpose, signal isolation, and impedance matching. And also the important thing is about we want high input impedance and low output impedance. It means the loading effect. The loading effect, we can reduce the loading effect by using op-amp. This is the necessity of op-amp in your active filters. Now we will go for the construction and working of your low pass active filter. Look here, as usual, you know about the op-amp, because you are using an op-amp, and as usual, first I will go over this is in general about RC low pass filter. This is your you are applying the input here, Vi, and you are measuring the output here, V0. This is R1, C1. It means in the low pass filter, you are applying the input to the resistor and you will measure the output across the capacitor. I am saying in simple RC filter. And important thing, your resistor in series and capacitor in parallel according to the with respect to the input. It means here this is nothing but a RC filter. This RC filter you are connecting to the non-inverting terminal of the op-amp. This RC filter you are connecting to the non-inverting terminal of your op-amp. Right? And can draw the neat diagram. And also similarly, if you want, you can go for high pass filter. Only small change in high pass filter. Consider in capacitor. You are applying the input to the capacitor. This is nothing but the Vi, and this is nothing but your V0. This is C1 R1. The difference is about high pass filter. You are applying the input to the capacitor and you are measuring the output across the resistor. This is about the high pass and low pass in construction of high pass and low pass in general filters. Now same, this high pass and low pass filter can be connected to the op-amp in the non-inverting mode. I can draw the very big diagram if you want. Yes, we are going for the low pass filter. As usual, you are using a resistor, a feed you can apply the input here. Now this is nothing but your R1 C1. Look here as usual you are having biasing voltages, positive VCC and negative VE, and here there is the output. It means, as I said already, only you are connecting a R and C low pass filter to the non-inverting terminal of your operational amplifier. You are connecting a low pass filter R and C, RC low pass filter, and this your actually the RC low pass filter is connected to the non-inverting terminal of your operational amplifier. And here whatever the input here you are applying, that input will be allowed here because it will allow the low frequency signal, that whatever your output of the filter, that is acts as input for the non-inverting terminal of operational amplifier. You are applying the different frequency here, you are applying the different input voltages, or you are applying the input voltage here, because this input voltage, this RC filter, it allows only low frequencies, and that allowed low frequency will be acts for the input for the your non-inverting amplifier. And as usual you are using an EV, the voltage given, because you are considering an non-inverting amplifier. As we know already, non-inverting amplifier, the voltage gain is nothing but the voltage gain is nothing but 1 plus RF by RI. The voltage gain for the non-inverting amplifier is nothing but 1 plus RF by RI, and also we know the cutoff frequency. The cutoff frequency is nothing but 1 divided by 2 by R1 and C1. Look here, here the important thing is about why you are connecting the low pass filter to the non-inverting terminal, because as I said, we want more amplification, we want more gain, because we want 1 plus RF by RI. If you connect the low pass filter to the inverting, you are not getting more gain. But if you consider connecting the low pass filter, the RC low pass filter to the non-inverting terminal, we want more gain, or we want more amplification. And important thing is about the cutoff frequency. It is a particular frequency. At that frequency, up to that frequency, your filter will allow the signal. After that cutoff frequency, your filter is not allowing the signal. This is nothing but the cutoff frequency. And also you draw the frequency response. You draw the frequency response of your low pass filter. And here you can go for the cutoff frequency, that is FC, and here it is frequency, and here it will be your AV maximum. This is nothing but 0.71 times AV maximum. Or you can write AV maximum by root. Look here, this is your AV, the voltage gain. Yes. First, so many times this question asked for 5 marks in your exam. Explain the construction and working of first order low pass active filter. First, you have to draw the need diagram, and as I said, you are connecting the RC filter, you are connecting a low pass filter to the non-inverting terminal, and your RI and RF will give the That depends on feedback and input resistance value. And as I said, you people, here the important thing you are studying about the low pass filter. It means it allows only low frequencies, and because of it allows low frequencies and high frequency will be attenuated stops. And how much it will allow the frequencies? It means some 0 to some cutoff frequency it will allows, and after the cutoff frequency it will be not allowing the signals, or it will attenuate most of the remaining frequencies. Cutoff frequency nothing but that is a particular frequency. Up to that frequency your filter will be allow the signals. The cutoff frequency it is a particular frequency. After that frequency what happens? Up to that frequency your filter will be allow the signals, or up to that frequency your filter allow the frequencies. This is about the low pass first order low pass filter. The important thing here, he may ask the question here, why only it allows the low frequency and why not the high frequencies? The name indicates low pass filter, and you see here the gain, or it will be see the frequency response. The gain will be constant for the low frequency, and that gain will be reduces for the high frequencies. It means why the gain will be constant for the low frequency and why the gain will be reduces for the high frequency. The important thing, as usual, the important thing you are considering the effect of the capacitor. You are considering the effect of the capacitor. Actually, the low frequency signal, your capacitor acts as an open circuit. For the low frequency signal, your capacitor acts as an open circuit. It means in the low frequencies capacitor is not there. In that time, whatever you apply the input, that is coming to the output. That output will be amplified and will come across our output of the op-amp. And for high frequency, what happens? For high frequency, your capacitor acts as short circuit. For high frequency, your capacitor acts as short circuit. It means high frequency will be going to the ground. It means because of the property capacitor, it will allow only the low frequency signals and it attenuates some of the high frequency signals. Once again, write it here. For the low frequency capacitor acts as a open circuit, or you can say we are having the XC, as usual known XC is equal to 1 divided by 2 pi FC. The XC is more, XC is infinity, or you can say high. Why only the low pass filter? It allows only low frequency. Why not high frequencies? Because for the low frequency, your capacitor acts as an open circuit. It means if it is open circuit, it is not there. If it is not there, means whatever you are given the input, that is directly coming to the output. And this output is acts for the input for the your operation amplifier or your non-inverting terminal of your op-amp. Then it will be further amplified to get the output. And for high frequency, we should not want high frequency in the output of the filter. And because high frequency, what happens? The high frequency where the capacitive reactance will be very less, or it acts as short circuit. Because high frequency, what happens? All the frequency, all the input will be going towards the ground. And for high frequency, what happens? For high frequency, what happens? The capacitor acts as a short circuit, or you can say XC is less, or you can say 0. Because that reason, what happens? It only allows the low frequencies and it attenuates most of the high frequency. This is about in general about the working and construction of your first order active low pass filter. Very simple. Why you are using active here? Because you are using an active component, you are using an op-amp. Why you are using op-amp here? The First thing, we want more amplification, we want more gain, or gain can be controlled. First thing. Second thing, op-amp is used as a buffer amplifier, and op-amp is used as a signal isolation purpose, and also op-amp is used for the impedance matching, or it is used for the to reduce the loading effect. And as usual, you are applying an R and C filter. You are considering the RC low pass filter. That RC low pass filter connected to the output of your RC low pass filter is acts as an input for the non-inverting terminal of your operation amplifier. You are connecting the RC low pass filter. Output of RC low pass filter acts as an input for the non-inverting terminal of your operation amplifier. And as usual, RI and RM, they are input resistance and feedback resistance will give the voltage gain for the non-inverting amplifier, and voltage gain for non-inverting amplifier is equal to plus RM by RI, and we want the cutoff frequency is nothing but 1 divided by 2 by R1 C1. The cutoff frequency is nothing but at a particular frequency. Up to that frequency, your filter will allow the signals, or it will pass the frequencies. After the cutoff frequency is not allowing, that is not attenuating the remaining frequencies, that is nothing but the cutoff frequency. And this is the frequency response of your low pass filter. Important thing, as usual, the gain will be constant for the low frequency, and gain will be reduces for the high frequency. Why the gain will be reduces for high frequency? Because of high frequency, your capacitor acts as a short circuit, and for low frequency your capacitor acts as an open circuit. That's why your filter can allow only low frequencies, and it attenuates or stop the high frequency. This is about simple way of your construction and working of your active low pass filter. Now we go for the another one important thing, that is about first order active high pass filter. You go for the second one, that also important, and as I said already, very small change in the circuit diagram. The remaining is as usual same. Here you consider the high pass filter. As I said already, the high pass filter, it is a filter or it is a circuit. It allows only the high frequencies and it attenuates or stop the low frequencies. It means here the important thing about high pass filter, it will be allows the frequency above the cutoff frequency. It attenuates or stop the below cutoff frequency signals. That is the difference about low pass and high pass. The low pass filter up to the cutoff frequency allows. After the cutoff frequency is not allowing. But high pass filter, the high pass filter will allow the frequencies after the cutoff frequency. Before the cutoff frequency will be, the signals will be attenuated or stopped. And once again we are using the same diagram here. Very small change in diagram. As I said, only can interchange the capacitor and resistor. Only can interchange the place of capacitor and resistor. As usual, same, everything is same. And here everything can feedback resistor. This is your post VCC, or can write once again we are using here the input resistance. This is complete. RF, and here you are connecting negative V post VCC. and here you can connect an capacitor. You can apply the input to the capacitor. This is your as usual C1 and the R1. You are using same formulas. The voltage gain for the, because in your high pass filter it is first order active high pass filter, because a high pass filter is connected to the non-inverting terminal of the operation filter. Because as I said, in high pass filter you are considering I apply the input to the capacitor and you measure the output across the resistors, or you can say with respect to input the capacitor in series and resistor in the parallel. And here, because of the property of the high pass filter, it allows only high frequencies and it attenuates parts of the low frequency signals. And whatever the output of your high pass filter, that output acts for the input for the your non-inverting terminal of your operation amplifier, and remaining this signal once again the amplified output from the output of the operation amplifier. And as usual, the voltage gain for the RF by RI, the voltage gain for the non-inverting amplifier, and as usual the FC, the cutoff frequency is same as it is 2 by R1 and C2. And the important thing is about the diagram. Diagram is about we got the FC. This is nothing but frequency. This is nothing but your AV. This is nothing but the EV maximum. And this is AV maximum by output. Or you can say 0.7 times the EV maximum. The important thing here, as I said already, the important thing is about for your high pass filter. As you just said, the cutoff frequency means it is a particular frequency. The important thing for high pass filter is nothing but after the cutoff frequency it allows the signals or frequency. Below the cutoff frequency it is not allowing the signals and not allowing the frequencies. It means their name indicates the high pass filter, it allows only the high frequency signal, it attenuates or it stops the low frequency signals. And as usual, the gain will be constant for high frequencies, and the gain will be increases for the low frequencies. Or you can say the filter is not allowing the low frequency signal. It only allows or it only passes the high frequency signal. And we may ask the question, why the filter or how the filter it allows only the high frequencies and why not the low frequencies? Look here, as usual, in the you are applying input to the capacitor. You are applying input to the capacitor, and as usual, for the low frequency, what happens for low frequency? For low frequency, your XC is more, or it is very high, or it is infinity. Because of the low frequency, your capacitor is very more. That's why it is not allowing the low frequency signals. Because of the, as usual, the XC equal to 1 divided by 2 by FC. Your capacitor reactance is very more for the low frequency, It is because of that reason the capacitor is not allowing the low frequency signal, and it only allows high frequency signal. For high frequency, what happens? For high frequency, what happens? For high frequency, Xc is small or it is very less. Xc is nearly about 0. That's why what happens? The high frequency signal will be allowed by the capacitor. Only the low frequency signal will be not allowed by the capacitor because of the property of the capacitor. And low frequency, your capacitor is very more. That's why it is not allowing the low frequency signal. For high frequency, your capacitor is the capacitor is very less. That's why it is allowing the high frequency signal. And in the overall, the important thing is about in your first order active high pass filter, it allows only the high frequency signal and it attenuates or stop the low frequency signal because of the property of the capacitor. And in the overall, the important thing is about it may be the low pass filter or it may be the high pass filter. The thing is that you are giving importance to the capacitor. Depending upon the property capacitor, and as I said, it may act as open circuit or it may sometimes it acts as short circuit. Depending upon the working of capacitor, your capacitor can allow or it can attenuate or it can stop the frequencies. This is about in brief about your active low pass and active high pass filter. The important thing is about why you are using op-amp in your filters and why it is called active filter, because you are using an active device. It may be the operational amplifier, it may be your transistor, or it may be a FET. And as I said already, why you are using the op-amp in your filters, because as I said, we want more amplification, or you want more gain, or you can control the gain, and also you can reduce the losses, or you can reduce the attenuation. And also the important thing is about we want very less loading effect, we want good impedance matching. That everything is given by your operational amplifier. And also as usual, your op-amp is also used as a buffer amplifier and it is used as a signal isolation purpose. Also it is used for your unity gain amplifier. This is about the importance of your active filters. And last finally, what are the applications where you are using this active filters? It may be low pass or it may be high pass or it may be your first order or it may be second. Especially in communication. In communication we are using about this active filters. Also in the signal processing. In signal processing, in communication, and also in your medical electronics. Also you are using in your entertainment. Especially you are using in video games. In that video games also you are using about active filters. This is about today's class. As I said already, your op-amp can be used as a filter. How your op-amp can be used as a filter, and as we know already, filter nothing but it is a frequency selective circuit. It means it allows some frequencies or it allows some signals and it attenuates or stops some other signals or some other frequencies. That is about the in general meaning of filter. And also as I said in the beginning, there are so many types of filters. In broad you can classify analog filter and digital filter. Analog filter only they will allow the analog signals, and the digital filter they work for the digital signals. Analog filter they work for the analog signals. But you are considering analog filter, and in analog filter having the two types, active filter and passive filter. And as usual, the passive filter is nothing but constructed by using passive components. It may be resistor, capacitor, inductor. But active filter along with your passive, it is also having the active component, maybe op-amp or transistor or amplifier. This is about in simple way of the active filters. And in the next class we go for the remaining about the another important property of your op-amp, that is how op-amp can be used as a to D converter and D to A converter. You go for the next class. Thank you.